Toggling switches to show numbers is cool, but what if we could make a circuit think for itself? Instead of using a tape to measure distance, how about we design a digital meter that measures the distance of an object and displays it directly on a 7-segment display? Kind of like reading a serial monitor, but visually. But before we get into that, let's step back and understand how a 7-segment display actually forms its numbers. For example, how does it know how to show the number 2 or 3? We see 7-segment displays everywhere in clocks, calculators, and other digital devices. But how are those numbers really formed? A 7-segment display is made up of 8 LEDs. 7 of them are used for segments labeled A to G, and 1 more is for the decimal point. BCD stands for binary coded decimal. It's a way of representing decimal numbers 0 to 9 using just 4 bits of binary. For example, the number 5 in BCD is 0101. The number 2 is 0010. But to make this useful for display, we need a chip that takes those 4 binary inputs and translates them into the correct 7 segments output. When I close switch 4, that makes the input 0001, while the other switches stay at 0. The decoder reads that binary number and outputs the decimal value 1 on the display. Now, if we reset that and close switch 3, the input becomes 0010, which gives us a decimal 2. Instead of switches, we will using an ultrasonic sensor that measures distance, and we will display that distance directly on the 7-segment display. To do that, we need a microcontroller. I will be using an ESP32, and I have already written the simple code in the Arduino IDE. The code groups binary coded decimals from 0 to 9, and it does an increment automatically when a new distance is measured. Here is how it works. For example, if the ultrasonic sensor detects a distance of 1 cm, the microcontroller represents that number in binary using the BCD condition in the code. The decoder then takes that binary input, converts it into decimal, and finally displays the result on the 7-segment display. To take the distance from the sensor to the block, and it was exactly the same even if I moved the block, and taking the reading of its new position, and it was just as the same with the tape.